Welcome to the course TOP 30040W 1830 PSS or Photonic Service Switch for R7.0 Architecture and Hardware. Please take a moment and read the legal information on this screen. By advancing beyond this page, you agree to the terms of use and acknowledge this legal notice. If you have any questions about your computer being compatible with this course, call our technical support hotline at the numbers listed. Be sure to have the information listed on the slide ready for them in order to expedite the help that they will give you. Before we get started, please have a look at the controls of this web-based training. The side panel allows you to see the outline or menu, or view the voiceover script or called notes. The control bar along the bottom has a number of different features. It allows you to search for a topic, play or pause, and to go to the next or previous page. It has a volume control, shows the slide length status, and lets you repeat a single slide. Audio length by minute and second is shown at the top, while glossary and attachments are considered resources and can be accessed from here. When you are ready, select the Next Page button from below to continue. This course consists of Alcatel-Lucent 1830 PSS Portfolio, 1830 PSS4 Product Description, Protection Schemes, and 1830 PSS4 Management Interfaces. Upon completion of this course, you will be able to define the 1830 PSS4 Edge device, describe the role of the 1830 PSS4 into the telecommunications network, describe the topology and system architecture of the 1830 PSS4, identify the possible protection schemes of the 1830 PSS4, identify the management interfaces of the 1830 PSS4, identify the system hardware of the 1830 PSS4. In Lesson 1, we will cover where the 1830 PSS4 stands in the Alcatel-Lucent 1830 PSS portfolio. Upon completion of this lesson, you should be able to describe the 1830 PSS portfolio, describe the applications of the 1830 PSS4, define the possible topologies for the 1830 PSS4 networks. Let us look at the 1830 PSS portfolio offered by Alcatel-Lucent from CPE to Core. The portfolio covers everything from the 100G long haul to the metro region to the access point, using different mechanical solutions and configurations, but reusing most cards across the product portfolio and having a common network management. The mechanical solutions offered include an edge device, the 1830 PSS4, and several Metro Core devices, such as the 1830 PSS16, which is an end office shelf, or EOS, and the 1830 PSS32, which is a central office shelf, or COS. Also in the Metro Core, there are other mechanical solutions, which are the 1830 PSS36 and the 1830 PSS64. The 1830 PSS4 is a 2RU chassis with up to 4 service slots for different boards to configure terminals with fixed optical add-drop multiplexers, FOADM, or inline amplifier, ILA configurations. The 1830 PSS16 with up to 16 slots and the 1830 PSS32 with 32 service slots are the Metro Core solutions of the 1830 PSS portfolio for tunable optical add-drop multiplexers, or TOADM configuration. The 1830 PSS36 and 1830 PSS64 are the 1830 PSS nodes with OTN switching capacity. The 1830 PSS4 is designed to provide a flexible, power-saving, and low-cost optical transport network, or OTN, solution for metro access applications. It can be configured to provide FOADM, inline amplifier, and terminal or CPE solutions for the 1830 PSS 36, 32, 16 networks. It ensures full interworking and compatibility with the other 1830 PSS products. The 1830 PSS4 provides both high and low rate service applications with its small footprint and flexible characteristics for financial offices through fiber channel or FC and fiber connectivity or FICON interfaces and carriers with 10GE interface as well as with the 8G and 10G FC interfaces. The 1830 PSS4 also provides high and low rate services for residential networks, the Internet, and public networks through the use of fast Ethernet, gigabit Ethernet, and high definition and standard definition video interfaces. The PSS4 also supports low and high rate services for application servers, enterprises, and branch offices through the use of fast Ethernet, gigabit Ethernet interfaces, and STM1 interfaces. The PSS4 also supports services for the 2G, 3G, 4G base stations. Let us see where the 1830 PSS4 stands in a metro access network. The PSS4 can be interconnected with the other devices of the 1830 PSS family, such as PSS32, PSS36, and PSS64 in a mesh or ring topology. It can be managed and integrated on the 1350 OMS with other products of the 1830 PSS family. As shown on the screen, the 1830 PSS4 is an edge device for metro access applications having a wide range of possible interfaces, such as E1, STM1, STM4, STM16, and Gigabit Ethernet, which provide concentration of services over optical channels of 2.5 GB or 10 GB transmission capacity. Let us now look at the PSS4 connectivity as an edge device for metro access applications in detail. There are several possible topologies for the PSS4 as an edge device in the metro access network. The PSS4 edge devices remap 1830 PSS cards in two RU rack mount edge devices. These topologies are dual hubbing, metro access ring, and metro access spur. In the dual hubbing topology, the traffic is transmitted from one central office, or CO, using black and white or CWDM transmission to a different CO. Channels are added or dropped in intermediate sites through filters. In the metro access ring, the access ring traffic to remote locations are added or dropped off in DWDM metro core rings implemented with 1830 PSS32 equipments. Metro Access Spur has the same functionality as the Metro Access Ring, but with linear topology. Let us understand the interworking of the 1830 PSS4 with an 1830 PSS3216. 1830 PSS4 edge devices interwork fully with 1830 PSS32 and PSS16 in mixed configurations. These configurations are at protocol, management, and optical levels. At protocol level, a service originating in the edge device can be terminated by a line card of 1830 PSS32 or PSS16. At management level, an edge device can face an 1830 PSS for an end-to-end supervision. At optical level, a line network port SFP or XFP of an edge device can be connected to a client port of an 1830 PSS32 or PSS16 optical transponder. It is also possible to connect a DWDM channel of line network port of an edge device to an electronic variable optical attenuator, or EVOA card, of the 1830 PSS32. This helps to insert wavelength tracker modulation, or WT, in the channel and to adjust the optical power of the edge channel in the Metro core ring. It is also possible to use this equipment in standalone networks. It is possible to stack up to 8 PSS4 edge devices to form a unique hub node. In the CWDM Metro access ring, the different nodes allow certain wavelengths to be added and dropped or passed through by the use of CWDM static filters. In the Metro access point-to-point solutions, a black and white and a CWDM point-to-point solution are shown. Here are some of the possible topologies for using the edge device in a standalone network in more detail. These topologies are single-channel point-to-point network topology, CWDM point-to-point network topology, CWDM linear topology with OADMs, single-channel bus architecture, and CWDM bus architecture. This brings you to the end of this lesson. You should now be able to describe the 1830 PSS portfolio, describe the applications of the 1830 PSS4, define the possible topologies for the 1830 PSS4 networks. Let's now turn to the product description of the 1830 PSS4. Upon completion of this lesson, you should be able to describe the key features of the 1830 PSS4, explain the circuit packs supported in the 1830 PSS4. Let us now look at the key features of the 1830 PSS4. The 1830 PSS4 has a modular design and supports applications such as FOADM, CPE terminal, or inline amplifier. The 1830 PSS4 uses the same transponders as the 1830 PSS 1632, such as the 1DPP24M, 4DPA2, MVAC, 4QPA8, 11DPE12, 11DPE12E, 11DPM12, 11DPM8, 11DPM4M, 11DPM4E, and 112SDX1. It also uses the same amplifiers as the 1830 PSS 1632, such as AM2125A, AM2125B, AM2318A, AHPHG, A2325, AHPLG, and AA2DONW. The 1830 PSS4 provides security enhancements such as ACL on GNE, CIT port disablement, SSL key management, and UAL compatible with the 1350 OMS format. It supports ESNCP and Y cable protection and optional wavelength tracker. The 1830 PSS4 R7.0.x incorporates new features such as on-demand latency measurement for 11QPA4, on-demand latency measurement for 11QPEN4, and new pluggable TXFP support for latency measurement on 11QPA4 and 11QPEN4. Let us now look at the 1830 PSS4 chassis and slots. The 1830 PSS4 edge device is 2 RU high subrack that can be mounted in standard 19-inch, 23-inch, or ETSI racks, or wall-mounted using available mechanical adapters. Slot 1 supports the equipment controller, or EC, and is a pluggable unit. Slot 2 and 3 support redundant 110, 220 VAC minus 48 VDC or 24 VDC power filters or a mixed configuration of AC and DC power filters. The power filters and fan unit are pluggable and can be removed and replaced. Slot 4 and 5 support SFC or SFD, which are two half-height filters. Slot 6 supports the fan unit and comprises of 6 variable speed fans and 1 controller. Slot 7 to 10 support the service cards such as 2 half-height or 4 half-height pluggable OT or OA. Optical transponders, or OTs, are elements that perform an electrical to optical electrical conversion. The transponder's mnemonic of service card gives an indication of its architecture. Let's consider the 11 DPM12 OT. The first part gives the line rate. For example, an 11 DPM12 OT has a line rate of 11 gigabit per second. It could be 112 gigabit per second, 43 gigabit per second, 11 gigabit per second, or 4 gigabit per second. The second part specifies the line interfaces. For example, DP stands for dual plug line ports, which means that there are 2 line ports that will take an SFP or XFP module. Various modules can be used for different protocols or different distances. QP stands for quad pluggable, SC stands for single coherent, and ST stands for single tune. The third part specifies the user rate or functionality. For example, the user rate on the 11 DPM12 is M for muxponder. GE stands for Gigabit Ethernet Client Signal, and MM represents multi-rate multiplexer, which can take many different client signals and multiplex them into a single signal. Finally, the last part tells the number of client ports and can range from 1 to 24 ports. For example, the 11 DPM12 has 12 ports. Let us now look at the transponder cards supported by the 1830 PSS4. The 11 QPA4 and 11 QPA4A is a full slot, full height transponder with 4 client ports, black and white or CWDM XFPs, and 4 line ports, black and white, DWDM or CWDM XFPs. The client signals supported are STM64 or OC192, 10 gigabit Ethernet WAN or LAN, OTU2 with FEC, and 8GFC, 10GFC. Depending on the client signal configured, the associated line port can be an OTU2, OTU1E, or OTU2E. It is also possible to have client ports protected with electrical SNCP scheme or with Y cable protection. The 11 QPA4A is temperature hardened. The 1830 PSS4 supports 2 boards in each shelf. A new feature is introduced in R7.0 for measuring the on-demand latency in 11 QPA4. The 11 QPEN4 is a full slot and full height card in the PSS4 1632. It supports all the 11 QPA4 features and additional features such as client port 4x10G or 8G and 10G FC, 10GE LAN, OTU2, OTU2E, XFPs. Line port 4x10G or OTU2 and OTU2E line rate encrypted XFPs with full encryption of Layer 2 clients including framing and headers. 1+1 client and line protection, on-demand latency, and 11 QPA4. The 1830 PSS4 supports 2 boards in each shelf. The 11 DPM8 is a full-slot, temperature-hardened, and wavelength tracker supportive card. It supports 8x SFP for client ports and 2x XFP for line ports. The line side supports 2 CWDM or DWDM or black and white XFPs. The 11 DPM4M is a half-slot, temperature-hardened, and wavelength tracker-supported card. It supports 4x SFP for client ports and 2x XFP for line ports OTU2. The 2 line ports operate at OTU2 with a total line bandwidth of 20 gigabit per second with the support of GFEC, EFEC I.4, or EFEC I.7, or configurable FEC type. The pack supports ODU0 and ODU1 level ESNCP. The pack supports standard GCC0, GCC1, and GCC2 functionality at line side. Terminal loopback and facility loopback are supported independently for both line side and client side of each port. The 11 DPM4E is a dual pluggable multi-rate with 4 cross-client ports and line ports. It is an extension pack for 11 DPM4M that is designed to work together with the 11 DPM4M main pack. The 11 DPM4E is half-height, single-slot, and temperature-hardened card. It comprises pack status LED for client ports, and Ethernet activity LED for client ports. It supports various client types such as GE, FE, OC312 or 48, STM 1, 4, or 16, fiber channel, video, and any rate services. It also supports reserved timing interfaces. The 112 SDX11 is a single-slot, 100G optical transponder that supports an OTU4 bitrate of 111.809 gigabit per second on the line interface. The card supports 4x 28 gigabit per second NRZ MLSE with fixed, not tunable, and 100 gigahertz spacing, and 4x 28 gigabit per second ODB with tunable and 50 GHz spacing FOADM only. It supports 10 gigabit Ethernet LAN client interface on SFP plus pluggable module, ISL trunking on FC ports, 40GE or SR4 over 4x SFP plus through fan-out cable, and 100GE over 10x SFP plus through fan-out cable. It also supports user-selectable client interfaces, QSFP plus, pluggable modules for 40GE and 4x 10GE rates. The 11 DPE 12E board is a full-height card with 12x 1 gigabit Ethernet SFP client ports and 2 10 gigabit Ethernet XFP black and white CWDM or DWDM line ports. The 11 DPE 12E supports C-band DWDM 88 channels with tunable XFP. This card supports synchronous Ethernet with synchronization status messages, or SSM, processing. It also supports the Y cable protection on the line side at the OTU2 level. The card also supports ESNCP protection for 2-mate 11 DPE 12E and supports fast Ethernet for electrical and optical interfaces. The 4DPA4 board is a half-height, single-slot wide card. It has 8 SFP ports that support 4 any-rate SFP client interfaces, 2 SFP line ports, and 2 EVOA ports. This card supports 1+1 electrical SNCP option. The card supports fault processing and signal monitoring. It supports wavelength tracker with EVOA SFPs on the 2 DWDM line ports. The 4DPA2 board is a half-slot, half-height card with 2 client ports and 2 black and white CWDM or DWDM line ports. The client ports can be configured to transmit an STM16 signal or an 1 gigabit Ethernet signal. 4DPA2 does not multiplex the 2 clients. Client 1 is connected to line 1 and client 2 is connected to line 2. The client and line rates are the same. No OTN framing is inserted at the line port. This card also supports electrical SNCP or ESNCP protection support for 1 client port. 1830 PSS4 supports 4 4DPA2 boards in each shelf. Now, we will discuss the amplifier supported by 1830 PSS4. The 1830 PSS4 supports 2 optical amplifiers in each shelf as inline amplifier solution. The optical amplifiers cards supported by the 1830 PSS4 are AM2125A, AM2125B, and AM2318A as modular amplifiers, and AHPHG, A2325, and AHPLG as line drivers. The modular amplifiers AM2125A, AM2125B, and AM2318A are unidirectional cards that amplify the signal from the line-in port to the line-out port, extracting or inserting OSC management channel depending if the channel is cabled as an ingress or egress amplifier. The line drivers AHPHG, AHPLG, and A2325 are bidirectional cards that amplify the signal from the line-in port to the signal-out port, while from the signal-in port to the line-out port, it only adds the OSC management signal. The amplifier AA2DONW is a bidirectional OA with OSC for the PSS4 applications that is used to introduce a low-cost OTN platform in the access space. This amplifier has been introduced in R7.0. This brings you to the end of this lesson. You should now be able to describe the key features of 1830 PSS4, explain the circuit packs supported in PSS4. Let's now review the protection schemes for the 1830 PSS4 Edge device. Upon completion of this lesson, you should be able to describe the protection schemes supported in PSS4. One of the protection schemes supported by 1830 PSS4 is electrical SNCP or ESNCP. ESNCP is a line-side or network-side protection mechanism, which protects against loss of the line signal due to SFP failure, fiber interruption, or a malfunction of an intermediate NE node. ESNCP protection is implemented by permanent head-end bridging, that is, the same client signal is connected to 2 line ports that go through different routes, and dynamic tail-end selection, that is, a single client signal is received by the client port. The 1830 PSS4 also supports the protection scheme Optical SNCP or OSNCP. OSNCP is implemented with a Y cable. It is a passive device that splits or combines signals depending on its orientation. In this protection scheme, the transponders perform the protection switch. When the active transponder detects a loss of signal or degradation of signal, the service will switch to the protection transponder. Only one of the working or protection transponders will have the laser on at client port. So the major advantage of using the Y cable is that you can specify a level of signal degrade at the OT as a protection threshold. Protection switching can be set as revertive or non-revertive. The backplane is used to communicate with each pack to determine the pack that is active and is in protection mode. The circuit packs for ESNCP intraboard are 11 DPM8, 11 DPM4M, 11 DPM4E, 4QPA8, 11 DPE12E, and 11 QPA4. The circuit packs for OSNCP with Y cable splitter are 11 DPM8, 11 DPM4M, 11 DPM4E, 11 DPE12E, 11 QPA4. This brings you to the end of this lesson. You should now be able to describe the protection scheme supported in PSS4. Let's conclude this course with the 1830 PSS4 management interfaces. Upon completion of this lesson, you should be able to describe the management features supported by the 1830 PSS4. The 1830 PSS4 Edge device can be managed locally through Command Line Interface, or CLI, and Web User Interface, or Web UI. Both CLI and Web UI can be launched with a PC connected to the CIT port. CLI can be launched using a telnet session to the CIT IP address. Java runtime environment and a web browser is required for the web user interface. To have remote management access, management information is transmitted through optical supervisory channels, or OSCs, in the case of DWDM networks implemented with the 1830 PSS4. The OSC is a 1510 nanometer wavelength that carries an OC3 STM1 signal, or a fast Ethernet signal, based on the configuration applied to the equipment. The OSC channel is supported by an OSC SFP module inserted in the optical amplifier card of the 1830 PSS4, giving the possibility of extending the management from the 1830 PSS32 and PSS16 networks. As centralized network management systems, the 1830 PSS4 supports the 1350 OMS, the 1354 RM-PHM, the 1354 INC, and the 5620 SAM. The 1830 PSS4 management interfaces can be found in the equipment controller card. The RJ45 CIT port is always enabled and works just like the CIT port on the equipment controller on the PSS32. The CIT port can be DHCP enabled, and it will then assign an IP address to the laptop connected to it. ES1 and ES2 of the equipment controller card are used to daisy chain 1830 PSS4 shelves. The functionality of an OAMP is to insert and extract management information from the 1830 fiber network to an Ethernet network and a DCN to carry management information to the Centralized Network Management System, or NMS. This brings you to the end of this lesson. You should now be able to describe the management features supported by 1830 PSS4. You should now be able to define the 1830 PSS4 edge device, describe the role of the 1830 PSS4 in the telecommunications network, describe the topology and system architecture of the 1830 PSS4, identify the possible protection schemes of the 1830 PSS4, identify the management interfaces of the 1830 PSS4, identify the system hardware of the 1830 PSS4. This completes the course TOP 30040.